Yeah, so my name is Paul, and I joined Netflix a little over a year ago. I'm in Sangeeta's team. And in our team, we work primarily on developer tooling, and that's not what I'm going to talk about. So instead of kind of talking about all the things that we do in the company and in the team to improve developer productivity, I want to specifically look at what to do at the architecture level to improve productivity for our developers, and specifically the kind of device developers. So it's a very small subset of all the things that we're doing, but I think it's I found it very interesting to learn about this when I joined a year ago. So that's a picture of me during working hours. That's how we all dress. I also write books besides dressing weird. So I have a very strong Java background primarily. I wrote 2 books about Java, specifically in the modularity space, which is kind of a passion of me. I'm a Java champion, and in real life, I actually write a lot of other things than Java. I do actually write a lot of Java, but also a lot of JavaScript and a lot of Go. It's a really good mix of different languages, different things that we work on. So in our team, as I said, we mainly work on developer tooling, and it ranges from distributed test tooling that we build systems for, command line tooling that developers use on a daily basis, all sort of web UIs to kind of give insights in what developers are doing, build pipelines and deployment pipelines. So really a broad range of things that help developers do their work, basically. So, as I said, we're not going to talk so much about tooling specifically. I will show a little bit of that, but primarily I'm going to talk about architecture. And you might think that's kind of a weird topic for a developer productivity meetup, right? What does architecture to do with productivity? But actually, the architecture that we use at our API layer is designed primarily to really be able to iterate really fast on the devices, the UIs that people actually use to play Netflix. The architecture is designed to really iterate really fast on that side of the world. And I was going to kind of give an overview how that architecture kind of evolved, and currently we are kind of using 2 different architectures and moving to something completely new. I'm going to talk about why that happened and kind of the benefits of those different things. So first of all, what exactly do I mean by edge service architecture? I think a lot of people, when they see edge, including myself, when I first heard about it, they think about things like CDNs, and that's not actually what we mean by this. So edge service architecture, think about kind of the API. You have a device and it connects to your backend, and the way it connects to your backend to the backend microservices, that is kind of your edge architecture, and we'll go into much more detail about that. But one of the most important things that you want to keep in mind when designing this architecture is that we want to innovate. We want to be able to iterate really fast on the actual Netflix experience. That's one of the primary drivers in the way the architecture is designed. And of course, there are many other things that are important. It has to be stable and all that kind of things. But innovation is really kind of a keyword when you look at the architecture. And I think that's something that's not super common. In most architectures, that's not a primary concern. At least it's the first time that I actually saw it being used like this. And the question that we are kind of looking at to answer is, how do we expose our microservices to our devices? And how do we design an API that works well for all those different types of devices? Because as you know, Netflix plays on many different types of devices, on your phone, on your TV, on your Xbox. And all these devices are different. How do you design an API that works well for all those different types of devices? Well, let's start super simple. We have a bunch of microservices. And this is not exactly how Netflix started. At least this would also be way before I joined. But actually, a lot of companies are doing right. They have a bunch of microservices, and they have maybe one device or maybe two devices that are being served by those backend services. And maybe those services are all talking REST, and what we have is in this case, the TV basically talking to each individual microservice and asking for data. And that kind of works, but there's also a few downsides. The first downside being that it's not very it's not efficient if you look at the network traffic. You have to connect individually to every backend service, which means you have a whole bunch of connections going on to just build your first initial screen, maybe. That's just not very efficient. Especially if you think about mobile, it's just very expensive to have many connections open. Another problem is that if you use a microservice architecture, it's very likely that you have very denormalized data, which means that the different services that you talk to will have each their own representation of a customer, for example, or a user. But only maybe one of the microservices is actually responsible for the data. But you will get customer data from all those microservices because everything is related to the actual user. And which data is right, which data is most up to date, and what happens if you update data from the UI? How do you propagate that back to the backend services? These are all kind of difficult questions. And again, it's also just inefficient. You're transferring the same data over and over again. Another problem is that there's a lot of problems to solve on the client side. The client is now responsible to failover of talking to each of these different services. And maybe the APIs of those different microservices are all slightly different. So maybe it's actually difficult to have a very common error handling mechanism. And the main problem is that it's the responsibility of these developers on this side, right? The developers on the microservices side can't actually help that much for that. And of course, we have super tight coupling like this with the actual device and the backend services. How do we push out chances to one of those backend services? Do we have to coordinate every single chance that we make with our UI developers? That's going to be problematic at scale. And what's even more difficult is how do these different microservices all design an API that works well for the specific device? Of course, if this is one team working on the whole stack, then it kind of works, right? You know the needs of the device, so you can design an API that works well for it. But it's kind of, if the teams grow and there's a different team for each service that you run, this becomes more and more difficult. And it becomes also more difficult to have an API that kind of looks and feels the same everywhere. If every service defines its own API, it will get it will look kind of weird. And all these things kind of slow us down in innovation. It will be much harder to make changes on either the backend side or the front end side because there's a lot of coordination between those different teams necessary. And that in the end will just slow us down. But as I said, this is actually what most companies do. And actually a lot of systems that I worked on in the past and a lot of code reviews that I did on other people's systems, this is kind of where a lot of people are at. And that's not necessarily bad, because if you have just that one device, it kind of works. So I would say this is bad, but it kind of works. But of course, we don't have one device, you have a whole bunch of devices. And each device is kind of different. We have different data needs on every device. Every device will have different data needs at different times. And now this is kind of horrible. It was bad with one device, but it is just unmanageable. The tight coupling that we created with this model will just slow us down completely. The backend services can't change because they will break one of the devices. And the devices can't change because they need new stuff on the backend side, but we can't provide it. So this would just not work. This would be unmanageable. Because of course you also have more people working on this now, so more people on the backend side and more people on the device side. And it's just not going to work out very well like that. So kind of the common step to fix this is to introduce a gateway service. So instead of talking to each individual backend service, we introduce a new layer, a gateway service. That's the name most people use for this. And you just communicate with the gateway service, and the gateway service kind of forwards to the appropriate backend service. This is already a lot better. Because now the clients potentially only need a single call to get the data for, let's say, the initial screen. There's no direct coupling between the clients and the backend services. There might still be some indirect coupling, kind of hiding inside the gateway service, but at least there's more flexibility here, because now we can make changes on the backend side, and the gateway can kind of hide that where necessary and make it available for other types of devices. So we have just a lot more freedom to make changes. But we also still have one major problem, and that's that if our gateway service has one big API, that API will be kind of not working for anyone. It's not going to be great for all these individual devices. It kind of has to work for all the different devices, which mostly means that it's not great for anyone, right? You can't tailor it specifically for one device, because if you tailor it for that one device, it will be suboptimal for the next device. So it's a lot better than the previous model, but you still have limited flexibility on making changes on this side, because we have this one big API. You also see that this gateway service here will be kind of a big monolith. It's a super big API, and the more backend services we have that are exposed using its gateway service, the bigger that thing gets, and the harder it will be to make changes over there. So a lot better, but still not perfect. So I talked about this term edge and what it actually means. So I would say that part, you could call that the edge. And if you actually zoom in a little bit in what it means for Netflix, there's actually a little bit more involved. So we have our actually front-end routing tool. We have our API server, and we'll zoom into there to see how that actually works. And some of our tier 1 services are part of edge as well. And then each team or each part of this architecture has its own team that works on that. And here at the bottom, we have a developer experience team, which is the team that I work in. And we create developer tooling and all the things that I talked about specifically to support the edge teams. Which is not working. All right, so let's move on to the next step. We saw some of the downsides of having this one big gateway service. And the biggest drawback being that it's this one thing, and it will be really hard to optimize the API for all the different devices that we have. So what if you would say that you would have a gateway service for each individual device? So we have a separate gateway service for an Xbox and a separate gateway service for iOS devices, and so on. Well, for the device owners, this would probably be great, because now they get their super tailored, super efficient API that just works for them, and they can iterate as fast as they want, and they can potentially make changes here on the gateway service as fast as they need. So in theory, this would be perfect. But it's also a little bit impractical, because who is going to own these gateway services? Who is going to implement them? We could decide that the actual UI teams would do that. But being UI developers, they are not necessarily kind of the right team to own these kind of highly scalable API services. It's just kind of a different field, right? On the other hand, if we would have a complete team managing just a gateway service for each individual device, that would also be super expensive. We would end up solving the same problem over and over again. Because each of these gateway services will have to deal with how do we talk to those backend services, and how do we deal with failover and things like that. And if we solve that individually for all the device families, it would just be too expensive. We would be solving the same problems over and over again. So this is kind of the model that we want to go to, but actually running this as a completely separate service is just not super practical. But this is the model that we're moving towards. So the architecture that most of Netflix runs on today looks something like this. So we have our different devices, and our different devices all connect to an API server. And this is again kind of our gateway service. But instead of having this one API served by the API server, the API server actually serves adapter scripts. And this adapter script is part of this world. And the UI teams write those scripts to access the backend services and to tailor the data that they need specifically for their device. So the UI teams can deploy these scripts and write those scripts, get all the data, and get it specifically tailored for their needs. So this is kind of best of both worlds in some way. And we will also see the next generation of this architecture in a moment. But it's kind of best of both worlds because we do have the super tailored device-specific APIs, so it's very efficient. But at the same time, we only have one API server to manage. And of course, managing an API server is kind of a big deal because if that goes down in production, it's kind of a big problem. So let's zoom in a little bit on what an adapter service actually is. So typically, let's say that our device needs some JSON data. It doesn't necessarily have to be JSON, but let's take that as an example. And let's say that we need something about a user profile, and we need some data about a specific video, and we want a thumbs up rating or the thumbs rating. And to get this data, we actually need to talk to 3 different backend services. We need to talk to the profile service to get my profile name. We need to talk to the video service to actually get metadata about our video. And then there's a rating service to get my thumbs rating. And the device kind of just needs all of that. So for the device point of view, we want to have one call, one API that gives us the data. While in the backend, our adapter script takes care of talking to those different services, taking care of error handling and things like that, and combining that data. And in this architecture, these scripts are written in Groovy, which is not necessarily a language that all the kind of UI teams are super familiar with and very happy with, which brings us to the next architecture in a moment. And the scripts are kind of locally developed and uploaded to the API server. And it's almost a function as a service from the developer point of view, which is not a super clearly defined term, so hence the question mark. But from their point of view, they basically write a script, upload it somewhere, and it works. It works in production, and they don't have to worry too much about how it actually gets deployed, how it actually gets scaled out, how we deal with failover of servers and things like that. From their point of view, they write a script, upload it, and they're done. And that's actually for them a very good experience, mostly. Okay, give up on this. However, there's also some downsides. The biggest downside being that if one of these adapter scripts start misbehaving, maybe because someone just wrote a bug, or they depended on a client library that had a bug. Something goes wrong, it can have actually a really big blast radius and taking potentially the whole API server down. And of course, if the API server goes down, Netflix doesn't work anymore, and that's kind of a problem. And just the fact that we have a single point of failure for all those different devices, that's kind of scary. And of course, there's all kind of things that we can do to protect ourselves against these kind of failures, and we do that quite successfully because there is not a lot of downtime. But still, the whole idea of having this one point of failure and one change can potentially affect devices that have nothing to do with that change, it's kind of scary. And then of course we also have folks like Luke Cage kind of trying to break our system apparently. But this is mostly an example of if something goes wrong, if there is any form of downtime for whatever reason, it kind of blows up and immediately picks up on it. So it's just super important to us that this doesn't happen. So in a next generation of our architecture, we try to reduce that blast radius that we have with this big API server. So instead of having this one API server where all the different adapter scripts live for the different devices, we now take each family of adapter scripts and deploy that in a container. And by doing so, at that runtime, I should say, the blast radius is just much smaller. If something blows up here, it should not affect the other services that are for the other devices. So this is just on an architectural level much safer. The reason we can do that now, because it looks very much like what I talked about previously with having a gateway service per device family, which is impractical. The reason we can do that now is that we start leveraging containers here as well, which makes it much less costly to kind of spin up these new clusters of servers specifically for a new set of adapter scripts. And it all runs on our own container platform, Titus, which is very recently open sourced. But with this model, although the adapter scripts are kind of doing the same thing, they now run all in isolation. And in a moment, we'll also see that on the developer experience side, this also has really big benefits. I talked about all of this. So I kind of skipped over a little bit about how those adapter scripts actually work. So I gave this example of getting some data from different backend services, but we didn't really look into how that works. If this adapter script had to kind of solve the problem of talking to those different backend services for each adapter script, that would again be super costly, right? You would be solving the same problem over and over again. So instead of doing that, we use a library called Falkor there. Falkor, also open source. It's kind of an interesting technology. It's a technology that kind of changes the way you think about APIs. And as an example, this would be kind of a traditional API, and it could be a REST API that looks very similar like this. But either using REST or gRPC or whatever, you kind of have to define methods almost where you get, I want this piece of data. And then I want this piece of data, and then you get both pieces of data, you have to combine them together in one result that will be consumed by the actual device. Instead of that, by using Falkor, we don't really have an API. We just have a large scheme of things that we can get. There's a logical model that sits in front of all the microservices that we have, and we just define what data we want to have. So we look at all our data as just one big logical model. So for example, we can ask for the user's profile, and we want to get all the rated videos. We get one of them, and we want to get both the title and the thumb rating. And we also want to get a name of this profile. The way this actually works is that although I just defined declaratively that I want to have this data, Falkor, which kind of lives here, will actually talk to those different data services in the backend, get the data, and represent that that data that we have as one big model. And this model here is represented as a JSON graph. Kind of looks like JSON, but you will see that it's not quite JSON. So one of the very important things that it solves is that we have refs here. And a reference is kind of one point in the data that we point to the data, but we don't actually list the data there. And I have a better example of that. So again, going to the rated videos example. In our model here, we say that we have all videos rated, and that's a list of videos, basically. And of course, each rated video actually lists to a video, which has a title and episodes and things like that. Instead of having that data duplicated in my rated videos data listing, it has a reference to videos by ID, which points to the actual video data. And in there, we will have the actual video data, like a title. And as a developer, I can get this data by asking for the videos rated, and I can ask for both a title and a thumb rating. And these two pieces of data come from completely different backends, and I don't see that as a script developer. As a script developer, I just declare that I need both a title and a thumb rating. And Falkor will also take care of error handling and downstream errors that might happen when we talk to the backend services. And that means that sometimes I will not actually get a title, but at least I get my thumb rating. Probably the other way around would be more useful, but you kind of get a point. So instead of worrying about all that communication with the actual backend services, that's what Falkor does. And as a script developer, I just define the data that I want. And finally, this new architecture is also improving our developer experience. As a script developer, as I said previously, script developers had to write their scripts in Groovy and upload it to the API server, basically. And the nice thing about it was that they didn't have to care about deployments and scaling and things like that. The downside being that there was not a really good debugging experience. Because you have this kind of almost function as a service model, you kind of have to throw it over the wall, hope for the best, and if it goes wrong, you have to kind of debug on the API server almost. And of course, we had tools for that, but it didn't quite feel like the normal developer experience that you would get as a, let's say, Node developer, where you have step debugging and your IDE and things like that. So in our new model, which is all based on containers, a developer will actually run a container locally, and we have command line tooling to help with that. And they do actually get their own IDE, and they can use whatever editor they want, and they do get step debugging, and it kind of feels like a just a normal Node developer experience. And it is actually Node, so it's all JavaScript now. The other super important thing that they get is they get external routing to their laptop. So they start up their service on their laptop, and they get a URL on the Netflix domain. It supports all the cookies and things like that we have. And that way they can test their service running on their machine from, let's say, a device. And it will kind of work the same way as it would in production. It will mostly behave exactly the same way. And of course, it will make debugging mostly of problems that you will run into in production a lot easier, because you just have all of that locally, and you can just do a very good debugging experience. So this kind of shows how we shape an architecture to to innovate really quickly on the device side. And at the same time, there's just a lot of pros and cons to whatever approach you take if you look at developer experience. If you push it too far towards just write your script, don't worry about anything else, there's really good things about it, but there's also strong downsides to it. So you see that we kind of keep experimenting with the right approach of the right balance in this developer experience. And again, this looks really good, and we're migrating to this model more and more. And I think it's also just it's an interesting experience to kind of see that evolution of the architecture. I'm already over time, so that's mostly all the time that I have. Thanks very much. Do we have time for questions still?
Sure.
A little bit?
Maybe a few minutes.
And as you can see, we are also hiring in my team and also in many of the other teams. Yeah.
So you mentioned managing the blast radius like performance-wise, but like what do you do about security? How do you make sure that like some of these adapter scripts do not misbehave and try to do something nefarious?
Can you repeat the last part of the question?
Yeah, how do you make sure that these adapter scripts do not try to do something nefarious? They're written in Groovy, as far as I understand. How do you like ensure the security models for these guys?
So let's talk about so the question is how to ensure that the actual scripts don't do something harmful, right? And specifically also because they run in Groovy, so that means they have a lot of freedom. First of all, in the end, they still have to talk to APIs. So those scripts, although they run in the API server, but they kind of run in an isolated way as far as possible, using in the old model using class loaders. In the new model, they're completely separate containers, so that's again a better isolated model. But in the end, what they do is they talk to APIs. So there is, and using Falkor, so you can get all the data basically, but there's not necessarily much more that you would be doing. You could do a lot of harm, but this is also our teams that we kind of trust. So yeah, there's a lot of freedom that you get, but with a responsibility.
Thanks.
The library you showed to query your APIs, how is it different from GraphQL?
So the question is, how is Falkor different from GraphQL? So the Falkor was developed before GraphQL existed, or at least before it was open source. So that's one part of the answer. There's different timelines. The concepts are very similar. The inner workings are quite different. The kind of the way you write those routers, for example. I don't have a lot of experience on that side, on the GraphQL side, so I can't really fairly answer that. But they're basically solving the same problems in different ways. I think it's the only fair way to look at it.
Why not to like contribute to GraphQL?
Sorry?
Why not to contribute to GraphQL instead?
Because as I said, before GraphQL kind of existed or was available, there was already a lot of investment in Falkor, and that is a model that works really well here. Does that mean everyone should start using Falkor? That I can't answer.
So
not in a fair way, at least.
Like,
but
it's not broken, don't fix it.
What?
Like if it's not broken,
that's not necessarily true. So it's definitely not a case that we will write the technology here and stick with it forever. That's absolutely not the case. There's many examples where something was developed internally, something else better comes on the market, and if that's actually better and works for us, we would definitely start using that. I don't think that shows for GraphQL, at least yet.
There is one conceptual difference. GraphQL has a schema, Falkor is schema-less. So we prefer a more dynamic model. Again, there are pros and cons to the approach.
Thanks.
Yep.
I was curious about the local environment. You said there was one container. I was wondering if it was one many container, if you had containers on local and on the cloud, And if you have performance issues running containers locally.
Right. So the question is if there's one container locally or many containers locally, and how that also looks in the cloud. So for your local development experience, actually the tooling that we have starts several containers, and one container is kind of your main process that runs your scripts and the platform that supports that, and another container, for example, takes care of discovery, so discovery and registration. As a developer, you don't really see that. You don't interact directly with Docker, for example, but you interact with the tooling that we wrote on top of that to kind of ease that experience. But essentially, a developer will kind of see one container that they focus on. They have one container where their code lives and the thing that they actually interact with. In the cloud, it's a different story, because then, of course, you have much bigger scale than you would have on your laptop during development. So that can be thousands of containers per set of scripts.
So in terms of fault tolerance, I think that I missed the part there, but there's still a layer of secret breaking in the clients to the API, or the API now plays the role to actually making sure that you guys have a proper security breaking, fault tolerance, retries, everything. Or do you still need to do that in client? And the reason that I'm asking that is because I'm seeing more engineering teams such as Lyft, Uber, Google investing in service meshes to actually load off the burden of lead with this fault tolerance in the kind of container that's a sidecar as well, so it can be load off everything related to fault tolerance to those sidecars.
Right. So the question was, is fault tolerance handled somewhere by the API server, or is that still something that clients have to take care of? For a large part, it's handled by Falkor, and Falkor lives both on the client side and also in kind of the middle tier on the API server. So common errors like some backend server, some microservices misbehaving, it's overloaded, and it's not responding correctly. That's all kind of handled transparently, and as a device developer, you don't have to do much more work for that. Of course, on the in the mid tier on the actual API server where client libraries live, there someone has to implement that behavior. So I still have that, but we kind of offload it away from the device developers as much as possible.
Last question.
Sure. So how do you manage to do in terms of like new gauge got this outage? Yeah. So is there any API services which is region specific, so to boost the performance for one particular region where you might need more to publish content?
There's a lot of complexity to that, but basically we run in 3 different regions, and there's complete region failover. So if a region completely goes black, the other regions will actually have extra capacity to take that extra traffic, and that works super seamless. One interesting thing that I learned about when I joined, I still find it kind of exciting. Once in a few weeks, there's an exercise where one of the regions will actually be just shut off for practice, basically. And then you can actually see the traffic flowing to the other regions, and it's just super cool to see, especially because no one else sees it. So that's a model that you have to keep practicing, because otherwise, when failure happens, it will actually not work properly. Something you have to keep practicing. If something goes wrong, of course, you have the option to turn it on again. But by doing it on a very regular basis, you will actually be able, if something really bad happens, to fail over to the other regions, and usually that works really well.
All right. Thank you, Paul. Thank you all for coming.